shows three coplanar forces acting at the point O. The magnitude of the forces are 6 newtons, 8 newton and 10 newton. The angle between the 6 newton force and the 8 newton force is 90 degrees and the forces are in equilibrium. Find the other angles between the forces. So first we have to recognize what angles do we have to find. So we have to find this angle, which is between the 10 newton force and the 8 newton force. So we will call this angle A. And the other angle in this question is this angle, which we will call as B, which is between the 10 newton force and the 6 newton force. So as mentioned in the question, we are told that the forces are in equilibrium. That means that the forces acting upwards must be equal to the forces acting downwards, and the forces acting rightwards must be equal to the forces acting leftwards. So the 6 newton force and the 8 newton force do not have to be resolved, since they only have one direction in which they are operating. However, the 10 newton force is acting in this slant manner, which means we will have to resolve it. So it will have a leftward component like this, and it will also have a downward component. So let's say that the angle over here is known as theta. So that would make this leftward component equal to 10 cos theta and the downward component as 10 sine theta. So now that we have resolved the forces that need to be resolved, that means we can now solve the question. So we know that the forces are in equilibrium. So let's write down what would need to happen for these forces to be in equilibrium. So as I said before, the forces acting upward must be equal to the forces acting downwards. In that matter, that would mean that the 6 newton force must be equals to 10 sine theta. That is one equation. And then in the other case, where the leftward force is equals to the rightward force, that would mean that 8 is equals to 10 cos theta. Now we can use either of these two formulas to find the value of theta. So let's say I use the first equation that we did over here. So in that case, if we divide both sides by 10, that would mean that 0.6 is equals to sine theta. That would make theta is equals to sine inverse 0.6, which is equal to 36.869. So we're going to round that off to 36.9. So now we have the angle of theta, which is this angle over here. Now, as for the working, we are done with this, but you have to be careful and you have to notice that that is not the angle that they're asking for. As you mentioned before, we need this angle, entire angle over here, as well as this entire angle over here. So in order to find this angle, what we will realize that this entire line is a 180 degrees line. That means that this angle must be equal to 180 degrees minus theta. So we call this angle over here as angle A. So that means that angle A must be equals to 180 degrees minus 36.9, which is equal to 143.1. And as for this angle over here, that must be equal to, since it is a 180 degrees line, this angle is 90 degrees, and that would make angle B equal to 90 plus 36.9, which is 126.9. we need to give a final statement to indicate to the examiner what our answers are, because there are two angles mentioned in this question, and we need to tell the examiner how to differentiate between the two. So we can write it like this: A is equals to the angle between the 10 Newton force and 8 Newton force, as well that B is the angle between the 6 Newton force and 10 Newton force. So a particle P of mass 8 kg is on a smooth plane inclined at an angle of 30 degrees to the horizontal. A force of magnitude 100 newtons making an angle of theta with the line of greatest slope and lying in the vertical plane containing the line of greatest slope acts on P. The first part of the question says that given that P is in equilibrium, show that this angle theta is equal to 66.4 degrees correct to one decimal place, and find the normal reaction between the plane and P. So we know that we have to find out, one, the normal reaction, and second, we have to show and calculate the angle of theta, which should be equal to 66.4. Before we do that, we need to resolve the forces over here. This is angle P. This is particle P. So it has a weight which we know. We've been told the mass, which is 8. That makes its weight 80 kg. So since these are parallel lines, this will make this angle 30 degrees over here. And since there's a downward and leftward component, the downward component will be 80 cos 30, and the leftward component will be 80 sine 30. As for just 100 Newton force over here, this will become 100 sine theta, and the rightward component will be 100 cos theta. Another important information that they've given us is that it is a smooth plane. What that means is that there is no friction. And most importantly, there is a normal reaction which is acting on P, which I will write as R in the diagram. So they've told us that the particle P is in equilibrium over here. So as in question number 2, what that means is that the forces acting upwards must be equal to the forces acting downwards, and the forces acting leftwards must be equal to the forces acting rightwards. So let's write down the information by looking at the diagram. So when we see this first condition, that would mean we see in the diagram that the normal reaction is acting upwards, while this 100 sine theta force is acting downwards along with this 80 cos 30, which is the downward component of the weight. That means that R is equals to 100 sine theta plus 80 cos 30. And if we simplify the second part, which is, that would mean that this 100 cos theta force must be equal to the 100 sine 30 force, since they're both acting in different directions. So 100 cos theta is equals to 80 sine 30. So first we're gonna solve this equation first, since it only has one missing variable. So if we solve it further, 80 sine 30 is equal to 40, which makes 100 cos theta equal to 40. And if we divide 100 on both sides, this makes cos theta equal to 0.4, and that means that the value of theta is 66.4, as was mentioned in the question. So we've done one part, but now we have to also find out the normal reaction, which I wrote as R. What we only have to do is write down substitute the value of theta 66.4 into this equation. So r must be equal to 100 sine 66.4 plus 80 cos 30. That would make r equal to 160.9 newtons. So with that, we're done with the first part. This is part number 2 of question number 3. Given instead that theta is equal to 30, find the acceleration of p. So to find out the acceleration, we're going to use the forces formula, which is forward force minus resistive force is equal to the mass multiplied by the acceleration. So first we have to write down what we already know. So we know that the mass is equals to 8. And other than that, we're given the forward forces and the resistive force as well. So as for the forward force, we know that there is 100 Newton force. But what part of that force is moving it forwards, up the hill? That was the 100 cos theta force. And other than that, in resistive forces, we had the downward component of the weight, the leftward component of the weight, which was pulling it downwards. That was the 80 sine 30 force. Other than that, we have no friction, so we can now solve this question. So the forward force we'll write down 100 cos theta, and they're given us that theta is equal to 30. That would mean that 100 cos 30 minus 80 sine 30 is equals to 8, which is the mass, times the acceleration. So let's first solve the leftward part and simplify this. 100 cos 30 minus 80 sine 30 is 46.6. Divide by 8 on both sides, we get 5.82, which becomes the acceleration of p. So with that, we're done with question number 3.